So before we start chapter 10, this is a function composition refresher for you guys. So remember, function composition, we are not multiplying these functions, we're composing these functions. We're substituting one function in for x in another. So if f and g are functions, then the composite function or composition of f and g is defined by f open circle g, that's not multiplication, it's composition, of x, which means I want f of g of x, i.e. we're substituting g of x in for x in our function f of x, okay? And we've used substitution before when we were solving systems of equations. The domain of f composed with g is a set of all numbers in the domain of g such that g of x is in the domain of x. Okay, remember when we first talked about this, we take everything in the domain of g of x, the inside function, right? All restrictions on that. Then when we find our new function, we look at its domain as a whole, and we take any restrictions on that function, and then we combine those two domains. We take the intersection of those domains to find the domain of our new function. So let's work through some examples. So if I have f of x is 4x minus 1 and g of x is x squared plus 5, I want to find g composed with f of x. I like to rewrite it like this. This reminds me that I'm substituting in f of x for x in g. So I now have g of 4x minus 1. So I'm going to substitute, perfect time for a fire truck, I'm going to substitute 4x minus 1 in for x. So that means I have 4x minus 1 squared plus 5, because g of x was x squared plus 5. Remember, I can't just distribute that square. I do have to FOIL. So I have 16x minus 4x plus 1 plus 5. My final answer is 16x minus 8x plus 6. Now I want to find g composed with f of negative 2. There's two ways I could do this. First, I could substitute negative 2 into the function we just found, which right here, which is g composed with f of x. This is our function that we found. Or I could substitute negative 2 into f and then put my solution into g. I'm going to go ahead and do it. That's an x squared. I'm going to do it both ways. So first I'm going to substitute in green into my original function. So now I have g composed with f of negative 2. That's 16 times negative 2 squared minus 8 times negative 2 plus 6. So I have 16 times 4 minus negative 8 times negative 2 is a positive 16 plus 6. 16 times 4 is 64. 64 plus 16 plus 6. Well, 64 plus 6 is 70. Plus 16, that would give me 96. Cool. Let's see if I get the exact same answer, hint, hint, wink, wink, I should, if I substitute it like this. So I substitute negative 2 into 4x minus 2, and then substitute what I get for that into g. We'll do that in orange. So now I have g of f of negative 2, so I have to put negative 2 in for x. So I've got 4 times negative 2 minus 1. So I have g of this is 86. Sorry, 64 plus 6 is 70, plus 16 is 86. Okay, so I have 4 times negative 2 minus 1. That's going to give me a negative 9. So now I have g of negative 9. I'm going to substitute negative 9 into g of x. So I've got negative 9 squared plus 5, which is 81 plus 5, which is 86. going to drink a little more coffee before we start this next problem. But as you can see, right, we got the same answer no matter which way we did it. Next, I want to find f composed with g of x when f of x is x squared and g of x is x plus 3. So this means I'm going to substitute x plus 3 in for x and x squared. That's going to give me x plus 3 squared, which we got to FOIL out. That gives me x squared plus 3x plus 3x plus 6x plus 9. Next, I want to find f composed with g of 2. So I'm going to take f of g of 2. That's going to be f of 2 plus 3, which is f of 5, which is 5 squared, which is 25. Okay. Next, let's work focus. Okay, let's find the domain of a composition function. So given two functions, f of x and g of x, then f composed with g of x is f of g of x. So what we want to do is we want to find the domain of our composite function, which is all the x values that are in my domain of g and are also true for that composite function. So let's take a look at example 1. So what's the domain of f in this case? Well, the domain of f in this case, right, this is a parabola, right? What's the domain of parabolas? Well, it's all real numbers. This is a line, right? Its graph looks like a line with negative slope. The domain of this is negative infinity to infinity. So if I was to compose these functions as there's no restriction on any of the domains, the composition of those functions domain would also be from negative infinity to positive infinity. Let's take a look at example 2. F of x has a domain of negative infinity to positive infinity. G of x is the square root of x. Remember, I can only take the square root of positive numbers. So I'm going to have my g of x goes from 0 to infinity. If I was to go ahead and compose these functions, I would get the square root of x squared, which is just x, right? And that graph is a line. And we would think normally, okay, the domain of a line is going to be all real numbers. But wait, we couldn't substitute all real numbers in to our original function. So the domain of f composed with g, because we have this restriction on the domain of g of x, is going to be from 0 to infinity. And I have a bunch of other videos on YouTube about function composition. If you go to the main page and type in search, if you search for the word composition, all those videos will come up if you'd like to see more examples.